Hi guys, this is Miss Scott, and today we're going to cover section 7.2 in our geometry notes. Before we get to that, here is your bad joke of the day. What happened when the duck flew into the window? It got a quack in it. Yeah, oof, that one was really bad. Okay, let's move on. So section 7.2 is really similar to what we did in the last video when we were using that Pythagorean theorem to solve some right triangles. Now we're going to use what we call the converse of the Pythagorean theorem. And that's going to help us answer our essential question, which is how do you determine if a triangle is right, acute, or obtuse? Specifically, how do you do that using the Pythagorean theorem? So, the converse of the Pythagorean theorem assumes that you have three side lengths. So, if a squared plus b squared does in fact equal c squared, so if that works out to be true, then triangle ABC is a right triangle. All right, so we're going to use that idea with some given numbers to see whether or not the triangle that we're looking at really is a right triangle. Okay, so let's give that a shot. All right, now when you fill this in, you have to be careful. Your longest side is always C. So when I'm looking at this picture in example 1, I'm finding that 26 is the longest side. So that is what I have to fill in for C. It doesn't matter what order you fill A and B in, so I'm just going to go from left to right, call A 22 and B 14. Okay, so if we plug this in, we can actually just start plugging in right away. We'll plug in 22 squared plus 14 squared, and we're trying to see if that does equal 26 squared. And you can plug in this left side of the equation all in one line in your calculator. You don't have to do this in separate steps. When I did that, I got 680. Over here, 26 squared is 676. Well, we can see that those are not equal. Therefore, when we're told to tell whether the triangle with the given side is a right triangle, we would say not a right triangle because it did not work in the Pythagorean theorem. All right, so this is our answer right here. All right. Okay. When you're given radical roots like this, our radical side lengths, like 3 square root of 34, I can't really tell if that's the longest side. Now I know from this picture it looks like the hypotenuse, but remember, in geometry, we just can't go by what it looks like. So what we have to do is plug this into a calculator, and that's going to help us determine if it really is the longest side. So when I plugged in 3 square root of 34 into a calculator, I got about 17.5. So what that tells me is that that really is the longest side. So I can plug this in for C, I can plug 9 in for A, and I can plug 15 in for B. So if we do 9 squared plus 15 squared, and now when we plug in for C, we should plug in what we were given originally, not that decimal approximation. All right, so we're going to take 3 square root of 34, put some parentheses around it, and square it. Make sure when you plug it in your calculator, you put parentheses around it. Otherwise, it's not going to work. All right, so on the right hand or the left hand side, 9 squared plus 15 squared gives us 306. 3 squared of 34 squared, it turns out, is also 306. So, is this a right triangle? Well, these are equal, so yes, it is, or it's a right triangle. All right, so if you can make it work in the Pythagorean theorem, then it has to be a right triangle. All right, and last but not least, we have 4, 8, and 4 square root of 3. Again, we need to plug this into a calculator to see what it is as a decimal to determine what to use for A, what to use for B, and what to use for C. So if you plug 4 square root of 3 in your calculator, this is going to equal about 6.93. So if we label stuff, we can say our longest side is 8. So 8 is what we have to plug in for C, and then this 4 is A, and we're going to plug 4 square root of 3 in for B. So let's go ahead and do that. We have 4 squared plus 4 square root of 3. Again, you have to put parentheses around that. Squared is equal to 8 squared. All right, now on the left-hand side, 4 squared gives us 16. 4 square root of 3, it turns out, is 48. And then 8 squared is 64. So notice if you add 16 and 48, you get 64, which is equal to 64. So yes, this one is a right triangle. All right, so as long as you can prove that the Pythagorean theorem works for the side lengths, it has to be a right triangle. All right, now there are two theorems that kind of stem off of this idea. And the first one is called the Pythagorean inequality for acute triangles. And what that tells you is that if the hypotenuse squared is less than a squared plus b squared, then triangle ABC is acute. All right, and on the other hand, if you take the hypotenuse squared and it ends up being larger or greater than a squared plus b squared, then the triangle is obtuse. All right, so you have an obtuse triangle if the hypotenuse squared is bigger than the sum of the other two sides squared. All right, now let's put that into practice here. We've got two examples down below, and it says to classify the triangles with the given sides as right, acute, or obtuse. Okay, well, if we look at number 4, notice 4.3 and 5.2 are the smaller sides, so we have to plug in the longest side, 6.1, for C. I always put C squared when I do these type of problems. It just makes life a little more easier for us. A little more easy. So we're going to say 6.1 squared, that's C. And we are comparing that, so we want to see how that compares to 4.3 squared plus 5.2 squared. All right, so let's plug that into a calculator. 6.1 squared, if you calculate that, ends up being 37.28. And again, we're comparing that with 4.3 squared plus 5.2 squared, which is about 45.53. And notice that 37.28 is less than 45.53. So if C squared is less than the other two sides added up squared, it's an acute triangle. All right, so that's how you can use that theorem. All right, now let's try a second problem. Here, we'll do blue. Let's plug in this square root of 13 to see what that gives us. If you plug that in, you get about 3.6. So that tells me not the longest side. I need to use it as a leg. All right, so the 12 is definitely longest. That's going to be my C. And then I'll say 10 is A, and then the square root of 13 is B. So if we plug this in, C squared is going to be 12 squared. And we are comparing that. So we want to know how that compares to 10 squared plus the square root of 13 squared. All right, and these on the left side, 12 squared is 144. 10 squared is 100. The square root of 13 squared is 13, so this ends up being 113 over here. Or you can just plug it into a calculator if you're more comfortable with that. And notice 144 is definitely greater than 113, so it's an obtuse triangle because if c squared is greater than a squared plus b squared, it creates an obtuse triangle. All right, so a couple of examples using those last two theorems. If anything was unclear, shoot me a comment or a question down below in the comment section. Come find me. You know where I am if you're in my class. And we'll talk. So I appreciate you guys watching. Subscribe to my channel, like the video, and have a good day. All right, we'll see you next time.